All right, guys, Mr. Antonucci here, and we're jumping into section 6C, significance tests, the basics. So our targets for here are to state appropriate hypothesis for a significance test about a population parameter, interpret a p-value in context, as well as make an appropriate conclusion for a significance test. So I'm going to break this into three short videos as we go through each one of those. So confidence intervals are one of the two most common methods used for statistical inference. A significance test would be the second one. So let's look at what a significance test is. This is a formal procedure for using observed data to decide between two competing claims called hypotheses. These claims are usually statements about population parameters. So the first thing we got to do when we are working with significance tests is stating what we call the hypotheses. So there are two hypotheses, the null, which is notated with a capital H and a little subscript of 0, and the alternative, which is notated with a capital H and a subscript of A. So the claim we weigh evidence against in a significance test is called the null hypothesis, and the claim we are trying to find evidence for is what we call the alternative hypothesis. So this will all come clearer as we proceed through this. The alternative hypothesis is one-sided if it states that the parameter is greater than the null value or states that the parameter is less than the null value. Okay, so it's one-sided because we're looking for evidence that the parameter is just greater than or just less than the null value. A two-sided test states that the parameter is just different from the null value, so it could be greater than or less than. We're just looking for a significant difference. Okay, this is going to become important as we begin to set up our tests. So let's look at an example here where James is the manager at the Hawaii Pineapple Company and is interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A different irrigation system was installed in this field after the growing season, and James wonders if this change will affect the mean weight of pineapples grown in the field this year. So we want to state the appropriate hypotheses for performing a significance test and make sure we define the parameter of interest. So um, the null hypothesis in this case is H sub 0 mu equals 31. Okay, so that's the null, and this is what we are trying to find evidence against, essentially. So the claim is that the field produced pineapples that were 31 ounces. And since this is saying that the change in the irrigation system will affect the mean weight of the pineapples, it wasn't stated whether this change would be bigger pineapples or smaller pineapples. So we're just looking for a difference. So the alternative would be that the mean is not equal to 31. Okay. And then our parameter here um, is the mean weight of all pineapples in the field. That's why we're using mu, excuse me, for the population mean and not X bar. We'll talk more about that later, but the parameter, this is where mu equals the mean weight in ounces of all pineapples grown in the field this year. Okay, so it's important whenever you set up your null and alternative hypotheses to also define the parameter of interest so we know what the mu is referring to. Also notice it's defined in terms of the context. We didn't say it's just the weight of the pineapples. It's the weight, the mean weight in ounces of all pineapples grown in the field this year. So there's a couple implications there that it's not an individual pineapple. It's giving us the weight in ounces, and it's the weight of the pineapples grown in the field this year as opposed to um, any other time. Okay, so we got to be specific there. So a little warning here is that the hypotheses should express the belief or suspicion we have before we see the data. So don't look at the data first and then frame the alternative hypothesis. Okay, so essentially, before you look at the data, if you're doing research, it's appropriate to set up your null and alternative hypotheses before you begin analyzing the data, not after. Okay. And for our AP exam, the hypothesis always refers to the population, not the sample. So in our example here, we used mu and our parameter of interest, notice was called a parameter of interest, not a statistic, was the true mean weight of all pineapples. Okay, so be sure to state your null and alternative hypotheses in terms of population parameters. Typically, we're going to be talking about means or proportions. So it's never correct to write a hypothesis about a sample statistic such as H naught for P hat or the alternative for X bar, okay, because we're trying to make determinations about the population, not the statistic from the sample, not the sample statistic. So likewise, make sure to include the word population or true or all when defining your parameters so that it's apparent that you're talking about a parameter and not a statistic. All right, so that's it for this one. We'll continue on in the next video.